This video is on multiplying radicals. So when you multiply radicals, typically what you'll be doing is multiplying like you normally would. So distributing, foiling, things like that. And then simplifying each of the terms individually based on our rules for simplifying radicals. So I think the easiest way to do this is to look at some examples. The directions will typically say multiply, or they might say perform the indicated operation. And for the first one here, if I said I had the square root of 3x times, in parentheses, the square root of 27x minus the square root of 12. So you know you have multiplication here, even if I didn't say multiply, because you have a term next to something else in parentheses, that means multiply them together. And so to start here, what we really would do is we would distribute this through. Now when we multiply these together, because these are all radicals of the same index, in other words, they're all square roots, I'm able to multiply them together into a single radical for each term. So if I bring the square root of 3x times the square root of 27x, that's going to be the square root of, and then you multiply the radicand, the inside together. So 3 times 27, which is 81, and x times x, which is x squared. And then distributing this to the next term, a positive times a negative makes it negative. The square root of 3x times the square root of 12x, again, because they're both square roots, you can write it as one square root multiplying the insides. 12 times 3x is 36x. And then once you've done this, now we simplify. To simplify, we simplify like you normally would for radicals. So first off, this is a square root, so you want to ask yourself, is what's inside of here? What is the radicand? Is that a perfect square? Well, 81 is a perfect square because the number times itself gives you 81, namely that number would be 9. And x squared is a perfect square because it's an even exponent. So we can actually evaluate the square root of this right away. And so the square root of 81 is 9, x squared, the square root of that is x, so we have 9x. And then don't write a radical on this because remember, you've taken the radical, you've taken the square root. So we have 9x for the first term minus, here the square root of 36x. Is this all a perfect square? Well, 36 is a perfect square. Because the number times itself, that can give you 36. But x is not a perfect square because being to the first power, that's odd. So we're going to split this up into perfect square factors and non-perfect square factors. Now remember, I'm not evaluating it, I'm just organizing. So 36 is a perfect square. I'm going to put it in the perfect square factor. X is not a perfect square, and it doesn't have any perfect square factor actually because it's to the first power, so 1 is less than the index of 2, so the x will go in the non-perfect piece. And then we simplify here, 9x stays 9x, minus the square root of 36 is 6, and the square root of x stays square root x. Now, you can't combine these aren't like terms, right? You can only combine them if they're like radicals, like we saw in the previous section on addition and subtraction. So right here, that's it. It doesn't simplify any further, you leave it. Let's take a look at another one. If I said I had in parentheses the square root of x plus the square root of y, and then the second set of parentheses the square root of x minus y. Again, the operation here is multiplication, right? Because you have parentheses and parentheses, so that means you're multiplying. Each of these has two terms each, so what you really want to do here, it's a binomial times a binomial. Well, I shouldn't say that because they're not polynomials, but it's two terms times two terms, so you want to do what when you had a binomial times a binomial, which would be to FOIL this. So remember, FOIL means just a strategic way to multiply through. So we want to multiply the first, it's the f of FOIL, square root of x times square root of x is the square root of x squared. We'll talk about how it simplifies in a minute. The square root of x times a negative y. Now the y is not under a square root, so you can't put these both under the square root. The y is not under square root. Really just write them next to each other. A positive times a negative makes it a negative. You have y times the square root of x, you just write those next to each other. They can't be combined into one radical because the y isn't under a square root symbol. The inner from FOIL, a positive times a positive makes it a positive. Square root of y times the square root of x, because they're both under square roots, you write that as a square root of xy, multiplying the insides together. And then the last, the positive times a negative makes it a negative. Square root of y times y, the y is not under a square root, so it's y, and then just square root y, just write them next to each other. And now you want to simplify. And to simplify here, The square root of x squared, remember, you're just dividing the exponent by 2. If it's even, it comes out to a perfect square. So x squared is a perfect square. 2 divided by 2, which gives me x to the 1. You might recognize when you do a square root of x times the square root of x, the square root of something times itself is always going to give you whatever's on the inside, because the index of 2 will match the power of 2, so 2 divided by 2 will always give you 1. So you maybe will not show this step in the future, because the square root of something times itself is just the inside. Minus y square root of x, does that combine with this, square root of xy? Well, the answer is no. They're not like radicals. They don't have the same radicand. And it won't combine with this either, this minus y root y. So those all have to just stay. So we have minus y square root x plus square root xy minus y square root y. And the last thing you should do is you should check to see, does this simplify any further? In this case, you know, if you could simplify your radicals any further, you would, but none of these are perfect squares in here or have perfect square factors, so you would just leave it like that. Sometimes people are a little unsettled by that, but it's okay to have multiple terms, right? It happens. Let's take a look at another one here. Call this one letter C. If I said I had 4 plus the square root of 5 times 4 minus square root of 5. All right, and taking a look here, operation again is multiplication, and you know that could be parentheses around both of these and signifying multiplication. And we're going to FOIL. Again, we have two terms in each of them, and following FOIL, multiplying the first. 4 times 4 is 16. Make sure you just multiply those together. 4 times a negative square root of 5, a positive times that makes it negative. 4 times square root of 5 is just 4 square root 5. Remember, you can't multiply into the square root unless this was also under a square root. Positive square root of 5 times 4 is plus 4 square root 5. Again, you can't multiply that into the square root, so you just write them next to each other. And then my last term's a positive times a negative here. Makes this a negative square root of 5 times square root of 5. Remember what I mentioned just a little while ago. The square root of something times itself just gives you whatever was on the inside, so minus 5. The reason that's true, maybe I'll just point it out here, right, is that it's really the square root of 5 times square root of 5 is the square root of 25, right, which is just 5, or the square root of 5 squared, which is just 5. So whenever you have a square root of something times itself, right, you always get whatever's on the inside. The positive times the negative is what made it a negative in front. Don't lose that sign. And then we'll combine like terms. Well, negative 4 square root of 5 and positive 4 square root of 5, those are like radicals, and a negative and a positive of the same value always cancel to a 0. So these cancel right out, right? Negative 4 root 5 plus 4 root 5 is 0 root 5, which is just 0. And then 16 minus 5 here is just 11. So this comes out to 11. And if you notice, the middle terms canceled. Now that happened because of a very specific case we have here. And the specific case we have is when you have, the same factors, right, but with an opposite sign in the middle of each of these. They're called conjugates. And maybe I'll write it here in general. So in general, the conjugate of A plus B, right, if you have two terms being added together, is the same two terms but subtraction. So it is A minus B. Now, the special thing about conjugates is that when you multiply them by one another, the middle terms will cancel out. You actually have seen this before when you were factoring, because what it really comes down to is that you're going to get the difference of perfect squares. And let me show you how that happens. Just in general, if I have A plus B times A minus B, well, we're going to FOIL this. And A times A will give me A squared. A times a negative B will give me a minus AB. A positive B times A gives me a plus AB. And a positive B times a negative B gives me a negative B squared. Well, what happens here? Negative AB plus AB, same terms, opposite signs, cancel to a 0, so you're left with just A squared minus B squared, which was a difference of perfect squares. So when you have the conjugates, the middle terms are going to cancel. That's why when we factored difference of perfect squares earlier, it actually factored down to its conjugates, because it's what had the middle terms cancel out. So when you multiply something by its conjugate, it's really important to know the middle terms will cancel. So a shortcut would be to just multiply the first and the last together, because you know the middles will cancel out, right? Same thing I did here. I can multiply the 4's together. I can multiply the positive square root of 5 times the negative square root of 5, and I would still gotten the same answer. So the reason it's important to know this is that when you multiply something by its conjugate, the middle two terms cancel, which gives you a shortcut where you just multiply the first and the last and use those terms. Let's look at a few more examples here. So if I said, for example, multiply, again it could say perform an indicated operation, and I said I had 3x square root y plus square root of 2 times 3x square root y minus square root of 2. So you know the operation is multiplication because these are both in parentheses next to each other. And you have two terms in each of these. And the first thing you should notice is that these terms are the same terms but with an opposite sign in the middle. So these are conjugates. If these are conjugates, remember what the shortcut was. You can multiply just the first terms together. Alright, so this times that. And that would give me 3x times the 3x. Remember, you multiply the coefficients would give me a 9x squared. And then square root of y times square root of y, well remember the square root of something just itself is just whatever's on the inside, so times y, right? That's because you really have the square root of y squared. When you do square root of y times square root of y, it's the square root of y squared, which is just y. Now since these are conjugates, the outer and the inner are going to cancel when you multiply them. So instead of writing them out, I'm just going to skip over that and I'm just going to multiply now the last, because when you multiply conjugates, the middle terms will cancel out. So the last terms, a positive times a negative, makes this a negative, and then square root of 2 times square root of 2. Well, remember, the square root of something times itself is just whatever's on the inside, so just minus 2. And so we had 9x squared y minus 2, and that's actually the answer. Remember, the minus 2 is really because square root of 2 times square root of 2 is really the square root of 4, or it's the square root of 2 squared, however you want to say that. But these simplified down. I just did it within the steps. When you multiply conjugates together, multiply the first, multiply the last, the middles are going to cancel. Now if you didn't do this and you foiled it, you'd still get the right answer. You'd just be doing the extra work in the middle that just cancels out. Let's look at something that's slightly different. If I said I had this, 2 square root of 5 minus 6, and this is the quantity squared. Be careful here. So first off, when you see this in parentheses being squared, it doesn't mean that you're allowed to bring the square to each piece. Remember, you only can do that if it's multiplication or division inside the parentheses. You can't do it if it's addition or subtraction. So you can't just square this and square this. What it really means is that when you see something like this with the squared on the outside, it means write it twice. Multiply it by itself, right? So 2 square root of 5 minus 6 times 2 square root of 5 minus 6. And when you look at this, be very careful. Are these conjugates? The answer is no. All right, and the reason the answer is no is that these have the exact same sign. Remember, conjugates have the same terms but with an opposite sign in the middle, right? One has to be plus, one has to be minus. So since these aren't conjugates, you can't skip the middle. You need to actually FOIL the whole thing. So we'll FOIL this just like we did earlier. 2 square root of 5 times 2 square root of 5. Well, 2 times 2 will give me 4 for the coefficients. Square root of 5 times square root of 5. That's just 5, remember. The square root of something times itself just gives you what's on the inside. So it's really 4 times 5. The 5 is right next to the 4. Just keeping an eye on that. And then the outer, 2 square root of 5 times a negative 6. So positive times a negative makes this negative. 6 is on the outside, so 6 times 2 is going to be a minus 12 square root of 5. For the inner, negative 6 times 2 root 5 will be a negative, because positive times a negative will make that negative. 6 times 2 is a negative 12, and the square root of 5, there is no root to multiply by this, so you just bring it along, just like we did in the first time we did it. And then a negative 6 times a negative 6, so it's a positive 6 times 6, which is 36. Make sure you square that, 6 times 6. Don't just use 6, right? And now we're going to simplify. Now, the 4 times 5 here is 20. And if you could recognize that right away, you could have wrote it right there ahead of time. Negative 12 root 5 minus 12 root 5. These are like radicals, right? They have the same index and they have the same radicand, the same part on the inside. So combining these negative 12 minus 12, they don't cancel out because they have the same sign. So you're really going to keep this negative, right? You're going to add them together and keep it negative. This will be negative 24 square root of 5, right? Negative 12 minus 12 makes it negative 24 square root of 5. And then plus 36 on the end. And then combining like terms, we've got 20 plus 36, which is 56, minus 24 square root of 5. Don't combine these. These aren't like terms, right? They're not like radicals. You can't combine the 56 and the 24. A lot of people do that by mistake. You can't do it because they're not like radicals. So you can't combine any further here. You have to stop. Maybe we'll just look at a couple more. You might want to try these next two on your own. So after I write them, you might want to pause the video. So if I have 4 square root 7 plus 3 times 4 square root 7 minus 3. And the second one here I'll write is 5 square root of 3 plus 7, or plus square root of 7, sorry. Plus square root of 7 times the square root of 3 minus 4 square root of 7. Alright, so try these two on your own. So I'd pause it, try them out, and then come back and check your answer. So, looking at this first one, 4 root 7 plus 3 times 4 root 7 minus 3. First thing I notice about these is that it's the same terms with the opposite sign in the middle. So these are conjugates. So I only have to multiply the first and the last. So if I'm going to multiply the first terms together, 4 times root 7 times 4 times root 7, the 4's get multiplied to give me a 16 as the coefficients in front. Square root of 7 times square root of 7, remember, is just going to be 7, right? It's just itself, whatever the inside is. Because it's really the square root of 49, which, you know, comes up to 7. And that's my first. Now remember, the outer and the inner, because these are conjugates, cancel out, so I'm not going to worry about them. And then I'm going to multiply the last terms together. So a positive 3 times a negative 3 makes us a negative 9. So I got 16 times 7 and minus 9. We can simplify this. 16 times 7. If you're not sure, we can do it on the calculator quick. 16 times 7 is 112. Minus 9, which equals 103. So there won't always be radicals left in your answer either, right? Especially with conjugates. A lot of times what you're going to see in the following sections is that you're going to use the conjugate to actually remove radicals from the problem in a very specific way. And we'll talk about that a little bit later. The last example here, you've got, you know, 2 terms times 2 terms. Again, you know, in this case, are these conjugates? Well, no, they're not even the same terms. So even though they have opposite signs, right, they're not conjugates because the terms aren't the same. So you have to multiply all of them out. So all 4 terms get multiplied here. So 5 square root of 3 times the square root of 3 for my first step of FOIL will be 5 times square root of 3 times square root of 3. Remember, you multiply these, you're just going to get whatever was on the inside of the radical. So it's going to be 5 times 3. And then here we have 5 square root of 3 times negative 4 square root of 7. So positive times a negative makes this negative. Multiply the coefficients together, so 5 times 4, which is 20, and then multiply the square roots together. Square root of 3 times square root of 7 is the square root of 21. And then we're going to multiply the inner. So we have square root of 7 times square root of 3. They're both positive, so this will be positive square root of 21. And then we have our last terms, a positive times a negative, which will make this negative. Here the coefficient is really just a 1 times 4, it just stays 4. Square root of 7 times square root of 7, well, that's going to be 7, remember, whatever's on the inside. Right? Or you could say the square root of 49 and then simplify it to 7. Once you've done that, we're going to simplify everything we have down here. I've got 5 times 3, which is 15. I've got a negative 20 square root of 21 plus the square root of 21. These are like radicals. This is negative 20. What's the coefficient on the square root of 21? Well, really, there's like a positive 1 in front there. So negative 20 plus 1 is a negative 19, and then the square root of 21 comes along. And then negative 4 times 7 is a negative 28. And now we want to combine like terms and simplify any radicals we have. Remember, even though I'm not writing simplifying all of these, you always have to simplify completely to get full credit. So 15 minus 28 here, these are like terms, becomes a negative 13. Negative 19, square root of 21, does that simplify? Well, it's not a perfect square, then you have to ask yourself, does it have any perfect square factors other than 1? Well, the factors of 21 are either 1 and 21 or 7 and 3, so it doesn't simplify further, so I'll keep it as the square root of 21. That's it. These don't combine. They're not like terms. Make sure you leave them as individual terms. And that's your answer, negative 13 minus 19 root 21. So you multiply these similar to what you would have done in the past to multiply. It's just now that we have radicals, you have to think about, you can multiply radicals together as long as they have the same index, and then you can simplify the inside of the radical just like we have in the previous sections. So I would make sure you practice this, and hopefully this helps.